Okay, this is homework for Tuesday, April 19th. You're doing page 32, number 1, A through D. So, the school is doing a back-to-school fun festival, and they have two plans. Either you're going to pay $5 to get in, and then $1 per game, or $2.50 to get in, and then $1.50 per game. It says write equations for each plan. So for plan 1, it's $1 per game, so that tells me the slope, and $5 to get in, that tells me the y-intercept. Now plan 2, my slope is $1.50 per game. Remember, the words per give me a hint who the y-intercept, the slope. And then to get in, I have to pay $2.50. So those are the two equations. Now B says to estimate, that means guess the coordinates, so I should see like an x and a y coordinate, like this, of the intersection point of the graphs of the two equations. So it's asking us, if I were to graph these two, where do you think they would eventually cross? So at what point are the amount of games and the money made the exact same? And it says check to see if your coordinates work in the equations. So if you have not already made a guess for an x and y coordinate, then do that now. So basically, if my x is the number of games, and then my y is the money made. So I'm guessing at how many games will both of the plans make the same amount of money. So my guess is at 10 games, they'll both make $15. So those are my two coordinate points. That's my coordinate points for my solution. Now I have to check if those points work in the equations. So first for plan 1, which was y equals 1x plus 5, I need to put 10 in my x spot and 15 in my y spot. So I have 15 equals 1 times 10 plus 5. So I substituted my y and my x for my estimate. Okay, now I solve. 1 times 10 is 10 plus 5, and then I have 15 equals 15. So I knew that one was going to work because I based my estimate on the first equation, knowing that 1 times 10 plus 5 would be 15. So I know my solution works in this equation, but the question is, does it work in the other equation? So 15 equals 1.5 times 10 plus 2.5. So I substituted in my 10 for the x and 15 for the y. 15 equals now 1.5 times 10 gets me 15 plus 2.5. And then I have 15 plus 2.5 is 17.5. So this does not work. So my coordinate points, my estimate, is not the right answer. Not the solution. So on your page, I should see your own estimate, and you are putting your coordinates into the equation and solving. That is the way you're going to get credit for this homework. Okay, C, use the expressions or the equations in the two cost equations to write this and solve a singular linear equation. So basically it's asking you to solve the system algebraically, and we've learned this in class, where I have my two equations, y equals 1x plus 5 and y equals 1.5x plus 2.5. Now, since both equations are equal to y, that means I can set them equal to each other and then solve. So I have 1x plus 5 equals, and then I have the other equation, 1.5x plus 2.5. Okay, now I need to solve for x. I'm going to do all this in black. So I want to get x to one side, so I'm going to subtract 1x on both sides. And these ones go away. I'm left with 5 equals 0.5x plus 2.5, because 1.5x minus 1x is 0.5x. And now I need to get x by itself, so I'm going to subtract 2.5 on both sides. Now 5 minus 2.5 is 2.5. Equals 0.5x. And now to get x by itself, I have to divide by 0.5 on both sides. Now 0.5 or 0.50 goes into 250 5 times. So 5 equals x. Okay, so I have my x, and now I need to substitute that in to one of these equations to solve for y. So I'm going to substitute it into the first equation. I'm going to change colors to show that work. So I'm going to do y equals 1 times 5 plus 5. So I took my 5, x equals 5, and substituted in for the x in this equation. Now I just solve. Y equals 1 times 5 is 5 plus 5. Y equals 10. So the solution to the system is, I'm going to change colors again, the solution is 5, 10, which means at 5 games played, both plans cost $10. Okay? So you should have all the work for solving, setting the two equations equal and solving, and you should have the solution written down as a coordinate pair, 5, 10. Alright, D says, for what number of games would plan 1 be a better deal for participants than plan 2? So remember we had the solution of 5, 10. So at 5 games played, both plans cost $10. Now what if 6 games were played? Let's think about our equations. For plan 1, if 6 games were played, it'd be 1 times 6 is 6, plus 5 is 11. But on plan 2, 1.5 times 6 plus 2.5 would be 11.5. So any games, if I play any more games than 5, plan 1 will be cheaper. But if I'm going to play 5 games or less, plan 2 will be cheaper. So plan 1 is a better deal if you play more than 5 games. Okay, you should have all the work, and I will see you tomorrow.